Welcome to the DIY Honda Garage channel. In this presentation, we will conduct a detailed analysis of the diagnostic trouble code DTC P2720, specifically identified as Pressure Control Solenoid D control circuit low, pertaining to the Honda CRV models from 2017 to 2022. The focus will be on understanding the role of the pressure control solenoids in the continuously variable transmission, CVT, their significance within the vehicle's architecture, and why this particular code signifies an electrical issue rather than a mechanical failure within the transmission itself. The pressure control solenoid D is responsible for regulating pressure in the CVT, which impacts the overall driving performance and efficiency. It is pertinent to follow the diagnostic steps meticulously to pinpoint the cause of the circuit issue. We will also explore related components, symptoms, and thorough troubleshooting steps to assist in diagnosing and resolving the problem effectively. The Pressure Control Solenoid D is an integral part of the Honda CR-V's continuously variable transmission, CVT. Its primary role is to manage hydraulic pressure, which is crucial for the appropriate engagement of clutches involved in the transmission process. The solenoid is engaged by signals from the Powertrain Control Module, PCM, ensuring that the transmission adapts efficiently to driving conditions. In a Honda CR-V, this solenoid is typically located within the transmission assembly, necessitating careful access when performing diagnostics or repairs. An error like DTC P2720 indicates that the PCM has detected a low circuit signal from this solenoid, prompting further investigation into the electrical pathways, connections, and components that interact with it. Understanding this system's function will be critical in tracing the fault accurately. The possible causes of DTC P2720 center primarily around issues within the electrical circuits associated with the Pressure Control Solenoid D. As the code indicates a control circuit low error, it suggests that there may be a short circuit or an open circuit in the wiring that connects the solenoid to the PCM. A blown fuse, specifically the number D4 10A fuse found in the under-dash fuse relay box, is a potential contributor to the failure. If this fuse is found to be blown and replaced, further investigation into the circuit is essential to prevent future occurrences. Additionally, continuity issues or shorts to body ground in the wires connected to this solenoid could also lead to the P2720 code being triggered. Recognizing these possible causes helps in following the correct troubleshooting procedures. When DTC P2720 is logged, various symptoms may become evident. The most apparent symptom is likely to be related to transmission performance issues, which can manifest as hesitation, slipping, or irregular shifting behavior as the pressure control is compromised. Drivers may also notice a decrease in fuel efficiency due to the engine having to work harder to compensate for the transmission faults. The dashboard's check engine light will usually illuminate when the PCM detects this fault, alerting the driver to take action. If left unaddressed, these symptoms could worsen over time, potentially leading to more severe mechanical failures in the transmission system. Therefore, early detection and resolution of the issue are crucial. The first step in troubleshooting DTC P2720 involves verifying the problem through initial checks. Begin by turning the vehicle to the on mode without starting the engine. This action powers up the vehicle's computer systems. Next, use the Honda Diagnostic System, HDS, to clear any existing DTCs. Once cleared, start the engine with at least 1 second. It is essential to check for any pending or confirmed DTCs again with the HDS. This step serves as a means to confirm if P2720 is present. If the DTC reappears, it indicates a persistent issue within the solenoid circuit that warrants further investigation. If the code does not show up again, it might indicate an intermittent failure requiring attention to electrical connections and possible repairs. Following step 1, move on to the second troubleshooting step. Begin by turning the vehicle to the off lock mode. Then, utilize the HDS to jump the SCS line, ensuring the PCM is protected from potential damage during diagnostics. Wait for more than 1 minute after this action. Disconnect the PCM connector A, 51P to proceed. After this disconnection, turn the vehicle back to on mode. Use a multimeter to measure the voltage across test points specified on the PCM connector A. Specifically, measure between number 11 of PCM connector A and the body ground. If battery voltage is present, this indicates that the IG1 mis-sol wire is functioning correctly. In the absence of voltage, further inspection of the D4 fuse is warranted to determine if it is blown or if there's an open circuit in the wire itself that necessitates repair. The third step in troubleshooting DTC P2720 involves checking the resistance of the CVT lockup clutch control solenoid valve. Begin by turning the vehicle to the off lock mode once more. Again, jump the SCS line with HDS to protect the PCM during the testing phase. After waiting more than 1 minute, disconnect PCM connector C, 51P, to access the necessary connections. With the vehicle still in off mode, measure the resistance between test points specified, using number 3 of PCM connector C and the body ground. Ideally, the resistance should read between 5.0 and 6.3 ohms, which would indicate that the control solenoid valve is operational. If the resistance falls within this range, proceed to look for any updated service information related to DTCs, or proceed with replacing the original PCM in case a fault persists. In this fourth troubleshooting step, the focus shifts to checking for shorts in the LCC-LS line wiring. Start by disconnecting the solenoid wire harness A, 8P connector. It's essential to ensure the vehicle is in off lock mode to prevent electrical accidents during testing. Measure continuity between test points again, which involves the PCM connector C, 51P number 3, and body ground. If continuity is confirmed, it indicates a short to the body ground within the LCC-LS wire that must be repaired. If not, it suggests that an alternative fault exists further down the circuit, which may need further investigation. This step is crucial in isolating issues within the wiring that could lead to the DTC being logged. The fifth step in troubleshooting DTC P2720 involves examining the internal resistance of the CVT lockup clutch control solenoid valve. To begin, safely remove the valve body assembly from the vehicle. Disconnect the solenoid valve's 2P connector to facilitate resistance testing. Additionally, ensure the vehicle is in off lock mode during this process. Measure the resistance between the stipulated test points on the solenoid connector. You should expect a reading between 5.0 to 6.3 ohms, indicating proper functionality. If the resistance is outside of this range, the solenoid valve is deemed faulty and should be replaced with a new part to restore proper operation in the CVT system. In the final troubleshooting step, you will determine if there is a shorted wire in either solenoid wire harness A or B related to the LCC plus line. Conduct continuity testing between the connected points on the solenoid wire harnesses and the body ground of the valve body assembly. The vehicle must again be in off-lock mode, and the valve body assembly should be removed for access. If continuity is present, this indicates that there is a short to body ground in the LCC plus wire that must be addressed accordingly. If continuity is absent, you will need to check the wire between solenoid harness A, 6P connector, and A, 8P connector for any issues. This step finalizes the investigation into the wiring system associated with the control solenoids. After completing all necessary repairs and replacements following the troubleshooting steps for DTC P2720, it's essential to perform final repair verification. Begin by reassembling all connectors and ensuring that each is properly seated and secured. Next, use the HDS to clear any stored DTCs, resetting the vehicle's computer systems. Following this, conduct a test drive to confirm that all transmission functions are operating as intended. Pay attention to any changes in performance and check to ensure that the check engine light does not reappear. This verification is crucial to ascertain that the issue has been effectively resolved and that the vehicle's driving experience is restored to optimal levels. Once the repairs related to DTC P2720 have been completed, implementing preventive maintenance is key to ensuring long-term performance and reliability of the CVT system. Begin by regularly inspecting the wiring associated with the Pressure Control Solenoid D for any signs of wear, fraying, or corrosion at connection points. Monitoring the overall performance of the transmission during regular vehicle operation will help in identifying any irregularities early. Additionally, using only high-quality OEM or authorized replacement parts during any repairs can help prevent similar issues from occurring in the future. Following these maintenance tips will aid in prolonging the life of the transmission and ensure the vehicle operates smoothly for years to come. In conclusion, diagnosing and resolving DTC P2720 requires a systematic approach to understanding the implications of this error code. Focus on the roles and functions of the Pressure Control Solenoid D within the Honda CRV's transmission system to appreciate its importance. Following the outlined troubleshooting steps methodically will aid technicians in effectively identifying and rectifying the underlying issues associated with the error. Moreover, implementing preventive measures ensures sustained reliability and performance of the vehicle. By adhering to these principles, technicians can not only resolve DTCs promptly, but also enhance overall vehicle functionality and longevity. Please like and subscribe to the channel. See you next time.